Hello, welcome to solve this beautiful algebra question. D times D times D plus D equal to 10. How do we find the value of D? D times D times D could be written as D to the power of 3 plus D equal to 10. This implies that D to the power of 3 plus D, when we transfer 10 to the left hand side, we have minus 10 equal to 0. D to the power of 3 plus D minus 10 could be written as 8 plus 2 equal to 0. Let's proceed further. D to the power of 3 plus D minus times 8, that is minus 8, minus times plus 2, that is negative 2, equal to 0. D to the power of 3 plus D minus 8 could be written as 2 to the power of 3 minus 2 equal to 0. Rearranging this left hand side, we have D to the power of 3 minus 2 to the power of 3 plus D minus 2 equal to 0. You will notice that it is possible to put this guy in brackets. Nothing has changed. Now, recall that A to the power of 3 minus B to the power of 3 could be written as A minus B times A square plus AB plus B square. Take note of this property, it is very important. By comparing this left hand side with this guy, you will notice that A is equals to D and B is equals to 2. This means that when we substitute the value of A and the value of B into this guy, we are going to have, what is A? A is D minus what is B? B is 2 times A, that will be D square, plus AB, that will be 2 times D, which is 2D, plus B square, that will be 2 square, which is simply 4, plus this guy, D minus 2 equal to 0. Let's continue. You will notice that D minus 2 appears here, it also appears here. That means we can factor it out. So we have D minus 2 into D square plus 2D plus 4 plus 1 equal to 0, because D minus 2 times this guy, we have this back, and D minus 2 times 1, we have D minus 2 back. Let's continue. D minus 2 times D square plus 2D plus 4 plus 1, that is simply 5, equal to 0. This implies that D minus 2 is equals to 0, or D square plus 2D plus 5 is equals to 0. Clearly from this line, our value of D is equals to 2. This is the first solution, that is the real solution. Now, let us focus our attention on this quadratic equation. We can solve it using quadratic formula, that is, the quadratic formula says D equal to minus B plus or minus square root of B square minus 4AC all over 2A. From this quadratic equation, our value of A is equals to 1 and B is equals to 2, the coefficient of D, and C is equals to 5, the constant. D is equals to minus, what is B? B is 2 plus or minus square root of B. B is 2, so we have 2 square minus 4 times, what is A? Our A is 1 times, what is C? C is equals to 5. Everything over 2 times, what is A? A is 1. Let's continue. D is equals to minus 2 plus or minus square root of 2 squared, that is 2 times 2, which is 4, minus 4 times 1 times 5, that is 20, over 2 times 1, that is 2. D is equals to minus 2 plus or minus square root of 4 minus 20, that is minus 16, all over 2. D is equals to minus 2 plus or minus square root of minus 16 could be written as square root of 16 times square root of minus 1 all over 2. D is equals to minus 2 plus or minus, what is square root of 16? That is simply 4. Also, don't forget that from the complex number, square root of minus 1 is equals to I. So this guy becomes I over 2. Let's proceed further. D is equals to, this right hand side could be written as minus 2 over 2 plus or minus 4i over 2. D equal to 2 cancels 2, so we are left with minus 1 plus or minus 2 here 1, 2 in 4, that is 2, so we have 2i. This means that D is equals to minus 1 plus 2i, or D is equals to minus 1 minus 2i. Therefore, we cannot claim that the solutions are the first solution that we obtain, which is the real solution, is D equal to 2. The second solution, which is complex, is D is equals to minus 1 plus 2i. And the third solution is simply D equal to minus 1 minus 2i. This is the required solution for this beautiful algebra question. That's it. Thanks for watching.